In a similar manner to the software processes and products, the assurance cases tend to be reused, modified and extended to individual projects. To be able to establish the assurance case lines, the OpenCert tool and BVR tool have been utilized. The base variability resolution language defines variability orthogonally for any meta-object facility compliant model representing the base model. The generation of target configurations is performed with variability or VSpec, resolution, and realization. In this video, the aim is not to present the management of the variability of a complete automotive safety case line, but only a simple example to illustrate the solution. Thus, first an example is presented and then it is made vary by using the integration of OpenCert tool and BVR tool. The example consists of a fragment of an automotive safety case. More specifically, the fragment is modeled by using the assurance case editor of OpenCert tool. The argument fragment starts by instantiating the hazard avoidance pattern. It thus claims, G1, that each FLED's fuel level estimation and display system is acceptably safe, given a definition of acceptably safe. G1 is then refined into G2, by using the strategy S1, that is by arguing and claiming that all the identified hazards have been addressed. G2 is then broken down into G3 and G4. G4 is directly supported by the solution E1. G3 is refined into G5, which is supported by direct evidence E2. It might be noted that G3 is instead broken down either into G5 or into G6, depending on the filter type, Kalman or not, which in turn depends on the usage context, vehicle type, variation point. Finally, G5 and G6 are supported by direct evidence, E2 and E3. It represents one configuration of the family that can be made vary via the integration of OpenCert tool and BVR tool. The BVR VSpec model presents the tree structure with logical constraints to be checked during the resolution. G5 and G6 represent alternative argumentation fragments. The constraint druck implies not G5 indicates that the choice G5 must be excluded for druck resolution. The resolution models are automatically generated from the VSpec model for which the new command is used, but the choices needed to be included or excluded. The resolution models represent the two possible argumentation configurations, one in case of druck and the other in case of vehicle type different from truck, are there. The validation process is executed to confirm whether the resolution corresponds to the VSpec model. In the variability realization, the variation points are specified. Their execution is based on the selection of assigned VSpec in the resolution. Based on the specified substitutions, elements of a placement fragment are removed and elements of a replacement are injected. The placements are visualized in red color. In order to derive the configuration, the execute option in particular resolution is selected. To do this, the base model needs to be selected in the navigator view. The file name and location would be provided for the tailored models. Accordingly, the tailored model have been generated in the provided location. To visualize the tailored model, the initialize arg_diagram file command is executed. If the elements are not visible the diagram, we can open the OpenCert perspective, and then click in the diagram, we can see the elements under the outline view. All the elements under the case transient can be selected and dropped into the diagram. Finally, by clicking in the diagram, the Arrange All command is visible and is executed. The results have been visualized in the assurance case editor of OpenCert tool. Many thanks for your attention.